in this tutorial, we are going to look at some trigonometry that we are going to be using in physics class and talk about how the different sides of a right triangle are related. So first thing we want to do is just talk about the names of the different parts of a right triangle. When you have a right triangle, that means one of the sides is at a 90-degree angle. And the side across from, or opposite of that 90-degree angle, the longest side is always called the hypotenuse. But then we have two other sides that we need to give names to. If we have a certain angle labeled, I'm using a Greek letter theta, it's a circle with a line through it to represent that angle. When talking about one of the sides, we have the angle here in this situation is on the left. And so the side opposite of that, the side on the right, we call the opposite side. Opposite means the opposite side of the triangle, whether it's on from left to right or from the top to the bottom. The last side we call the adjacent side, because adjacent means next to. So we have the hypotenuse, the longest, the opposite, meaning instead of on the left side, we have the right side, and then the adjacent, meaning next to it. One of the theorems that you probably already heard about was called Pythagorean theorem, and it shows a relationship between all three of the sides. Here we have the square of the two smaller sides added together is equal to the square of the hypotenuse. We're not going to be using that one as much in this class, but it is a tool that we do have access to. Instead, what we're going to be using is our trigonometric functions, the sine, the cosine, and the tangent. And we have an expression, a mnemonic device, to help us remember how these different trig functions relate to the sides. And that is called SOHCAHTOA. SOHCAHTOA. And what it's telling us here is that the ratio of the opposite to the hypotenuse side, for the sine, is always going to be in a certain proportion. For a given angle, no matter how long the sides are, the ratio of those two sides is always proportional. And so here we have the sine of an angle. Now what this represents here, this simply represents a number that we can either look up or we can type into our calculator to get. It represents a number. And that is equal to the opposite side divided by the hypotenuse side. The cosine function, again, this simply represents a number. You can find that number by either looking it up on a chart or typing it into our calculator. That is equal to the ratio of the adjacent side to the hypotenuse side. Now those are the only two we're going to use here in this class to get the sides. So we'll use these two trig functions, sine and cosine, if we know a side and an angle in order to get the other side. If we ever want the angle in this class, we're going to use the tangent function. And we're actually going to use something called the inverse tangent. It looks like tangent with a -1. And the tangent function is the opposite over the adjacent. Okay, it's the opposite over the adjacent. Now that I'm looking at this, I apologize. This should actually be written as the angle equals the inverse tangent of the opposite over the adjacent. So it simply means to undo the tangent function. I will show you that a little bit later on. Okay, so let's look through some examples here and better understand what it is that we need to do for this class. Let's say we're given an angle, and we're given one of the sides, and we want to find one of the other lengths, okay, one of the other sides. Now, first thing you want to do is you want to label the different sides. This side here is the hypotenuse, because it is the longest side. The angle is on the left, so the opposite of left is on the right. So this side here is the opposite side. And then the last side remaining, the one next to the angle, is the adjacent. Now what we want to do is, since we want to find a side, we want to either use sine or cosine. To figure out which one we want to use, we use SOHCAHTOA. Because we want to find the adjacent side, and we add the hypotenuse side, the opposite is not involved at all. So that means we want to use the cosine. The cosine uses the adjacent and the hypotenuse. So we write it out as the cosine of our angle, which is 45, is equal to our adjacent, which is our unknown x, divided by the hypotenuse, which in this case is 20. Now remember that this cosine of 45 simply represents a number. Now if you have a calculator that does this, you can simply type in cosine of 45. Make sure though that you're in degree symbol, you're in degree mode instead of radian. But the other thing we can do is we can simply look it up on a table, a trig table. And the way that we would do this is we're going to look for 45 degrees, which is right here. Then it tells us what the sine, cosine, and tangent of 45 degrees is. Now we want the cosine, and so here is our number, 0.707107. Now we're just going to round that off to 3 numbers. So again, this represents 0.707. And that's equal to x over 20. At this point, we're solving for x. So to do so, we multiply by 20 on each side. Here the 20 cancels out. And we're left with that distance is 14.1. So again, first we label the sides, and that helps us decide which trig function we're going to use. Then we have to look up what that cosine in this case of the angle is in order to solve. Let's look at another one. Here we have a situation where again we're given an angle and we're given one side, and we want to find a remaining side here over this side. We've got to label that as y. First thing to do is to label the sides. Here this is the longest side, so that is the hypotenuse. Our angle is on the left, so the opposite of left is right. So this side is the opposite. And then the remaining side, the side that is touching the angle, is the adjacent. So now we're going to write down our SOHCAHTOA. In this case, we want to use a trig function that has opposite and hypotenuse. And the one that has opposite and hypotenuse is the sine. So we'll write down that the sine of our angle, in this case 25 degrees, make sure you're in degree mode, is equal to the opposite, which we don't know, divided by the hypotenuse, which is 75. Once again, remember that this simply represents a number that we have to either look up or type in our calculator. It is the sine of 25, so I look for the number 25 in my angles. And we want the sine, which is the first column. And if we look here that the sine, I'm going to round it off to 3 numbers, the sine comes out to be 0.423. So I go back to my problem. This is 0.423. That is equal to my opposite side, which was y, over 75. Going to multiply by 75 on both sides to get rid of the 75. And I get that value comes out to be 31.7. So again, the first step is to label the sides and then figure out which trig function you're going to use. And then we have to look up sine and cosines on our chart. Well, there's one last problem that I'd like to go over with you, and that is, what if we need to find an angle? So here in this one, we're going to find this angle, which we don't know, but we're given 2 of the sides. We start the same way. We're going to label our sides. The longest side is the hypotenuse. The angle is on the right. The opposite of right is left. And the side that's touching the angle, the one left over, is the adjacent. We're going to write down our SOHCAHTOA. In this one, we have numbers for the opposite and the adjacent. So we don't want the hypotenuse at all. We want the opposite and adjacent. So that is now the tangent. But we write it a little bit different on this one. We write down we're solving for the angle. And so again, we have the tangent, but we're going to put it as a -1 here. It just means to undo the tangent. Take the inverse tangent, we say. We still write it out, though, as the opposite, which is 40, over the adjacent, which is 32. I'm going to rewrite this. Inverse tangent. If I divided my calculator 40 and 32, I get the number 1.25. This one's a little bit different in how we solve. We're looking for an angle now. So now I go to my chart, and what I want to do is in the tangent column, that's the 3rd column, I'm looking for a number that's as close to 1.25 as I can. So here we have 0 to start, and it starts to just increase. Down here at the bottom it is 0.457. I need to keep going. Here's 0.509. We need to get to 1.25. So I keep going higher and higher and higher. Here I'm at 1. So now I'm getting closer. I need 1.25. Here's 1.23, and here's 1.27. Now here's where a calculator would be really nice. We could again just put in inverse tangent of 1.25 and see what comes out. But using this chart, I'm just going to have to round it off and see which one is the 1.25 closest to. And 1.25 is closest to my 51 degrees. It's closer to 1.23 than 1.2799. So that means that my angle is somewhere between 51 and 52. I thought it was closer to 51 based on my chart. So again, when solving this, we do the same first step. We write down, we label the sides, and then we figure out which trig function we're going to use. But now we write it down as angle equals, and we're going to put in our ratio here, and then look for that ratio in our chart.